Good afternoon, friends. Today we will see how to solve the problems using recursion, means dividing the problem into subproblems. We can able to divide the problem into subproblems. If we if you divide the problem into subproblems, you can solve the problem very easily. So I will straight away go with a simple problem that you can understand. By this, what I want to say, I will say by this problem. Suppose I was given with 9 stones. This 9 stones looks like a similar, but 8 has 8 has same weight and one has different weight. So by looking at these 9 stones, I am not able to say which one is the different one. So I was given with a simple balance where I can weigh the stones and find the odd one out of that. So I will take how many weighings to find the different one. Means uh, I will use the simple balance how many times to find the odd one out of 9. So if you see the normal thinking, so we will put 4 on one pan, 4 on other pan. If it shows the same balance, means same level, then ninth one will be the odd one, means remaining one, which is not in the pan, that will be the odd one. If in the simple balance, if one will go down because of overweight, that group has the stone has more weight, means that group has odd one. So we take the 4 and then we will divide into 2. We will put 2 stones on one pan and we will put 2 stones on other pan. Then on the 2 stones we will come across the different type of group, because in that 4 stones only one odd one is there. We will divide the 4 into 2 and we will weigh that. Definitely one pan will go down because of overweight. After that, we divide the 2 into 1. By this, you can get the odd one out of that. So here, best case is by one weighing you can able to say the different one. Worst case is by 3 weighings you can able to say the odd one out of it. But there is some approach. We can say the things very easily, means in a 2 weighings itself I can say the odd one out of 9 stones. By using the simple balance 2 times, I can able to say odd one out of that. How? Let So before going to the 9 stones, I will explain the simple base case so that you will understand the 9 stones problem also. If I has a 2 stones, to find the odd one out of that, I have to use the simple balance one time, right? If I has three stones in which one has more weight, to find the odd one out of 3 stones, I will use the simple balance only one time, because I will put one ball here, I will put one ball here. If these two are balanced, means nothing will go down or up. If these two are balanced, then the third one is odd one. If some stone will go down because of overweight, then that stone will be the different one, right? So by one weighing itself, you can say odd one out of the 3, means by using the simple balance one time you can able to say odd one out of the 3 stones, right? So here 9 stones is there. I will divide the 9 stones into 3 groups. Every group has 3 stones. So I will put 3 stones here, 3 stones here. The first case is, if the balance shows balanced, means nothing goes down or nothing goes up, then it is showing that these two are balanced, means both pans has same weight. So in the third group, the different one will exist. So from the three stones, to find out the odd one out of that, we require one time of simple balance. Means by using one time of simple balance, we can able to say odd one out of that. So every time you get two chances only, because if this balance is not balanced, suppose this goes down, means this is the uh, this is the group having odd one. So we will pick these three, and by another weighing we will say odd one out of it. Suppose this goes down, and we will pick these three, and we will use the simple balance another time, we will say odd one out of that. So in any case, we are saying that 9 stones can be sorted out, means odd one can be find out in two weighings. In two weighings itself, you can able to say odd one out of it. Suppose 27 stones are there. So 27 stones are split into three groups, means 9, 9, 9. So here also I will use the same case. I will put 9 here, I will put 9 here. If these two balance, then my different stone is in this 9, means remaining 9. If this goes down, my stone is in this pan. If this goes down, my stone is in this pan. So in every case, you are dividing the problem into sub problems. Here I have divided the things into 9, 9, 9. So in the first weighing, I can able to say in which group it is there. After that, group has 9 stones. So 9 stones, odd one out of the 9 stones can be said in two weighings. So 20 stones having the same weight. To find the odd one out of that, we require only three weighings. So by this you can form a pattern also. What type of pattern? Suppose n stones are there. Suppose n stones are there. You can split it into three groups of equal n by 3, and then we can divide that n by 3 into another three groups, means finding the odd one, and we will divide the subgroup into another three groups. We divide the subgroup into another three groups unless until we reach the three balls concept, because three balls can be solved by one weighing itself. So I can I can form a statement here like this: finding the different one out of n stones can be judged by log base 3n times using the balance. Suppose I have a 243 stones are there. One odd one is there in that, having different weight. So by using simple balance 5 times, I can able to say odd one out of the 243 stones, right? So you can solve this type of problem using recursion. Means in programming, recursion is there. A function called itself is called recursion. By using recursion concept, you can able to solve this problem. So there is another concept is also there. Like suppose this is a grid problem. This is the same problem like the before one. So here I had a m number of rows, n number of columns. So here I will start at the first block, means starting block. To reach the ending block in a m into n grid, how many unique ways are there to reach from starting box to ending box? You can move horizontally or you can move downwards, means you can move vertically, means you can move horizontally, or you can move vertically, or what we can do, we can move to bottom, right? So if one block are there is only one way. If one row, two columns are there is only one way to reach the end. If one row, three columns are there is only one way to reach the starting to ending. There is only one way. Suppose 1 comma n is there is only one way. N comma 1 is there, only one way, because 1 comma n and n comma 1 is like the same. If you tilt the thing into 90 degrees, 1 comma n comma 1 both are same. So if I increase the one row and one column here, 2 into 2 means 2 rows, 2 columns. I will find how many paths. Here I will go from 1 to 3, 3 to 4. This is one path. I will go from 1 to 2, 2 to 4. This is one path. So total two paths are there to reach from first block to fourth block. First block is the starting one, fourth block is the ending one. So there is two ways. So if you see 2 into 3, if you see 2 into 3 means 2 rows, 3 columns. Suppose you are starting here. Suppose when I go here, I face 2 into 2 block, right? When I go here, when I move from this block, I will face 2 into 2, right? This 2 into 2 grid offers two ways. If I move here, then I will see what? I will see 1 into 3. So 1 into 3 offers only one path. So totally there are three ways are there to move from starting block to ending block. There are three ways are there. So 2 comma 3 is same as 3 comma 2. So only three ways are there to move from starting block to ending block. Suppose 3 comma 3 grid is there, means 3 columns and 3 rows grid is there. We can split that into 2 comma 3, means suppose we go here, we will face what? We will face two columns, 3 rows, right? 3 comma 2. Suppose if we go here, we will face what? Two rows, 3 columns, right? So if I move here, I get 3 comma 2. If I move here, I get 2 comma 3. So earlier I have discussed 2 comma 3. How many unique ways? 6 ways, not 6 ways. That is 3 ways only. 3 comma 2, 3 ways. Total 6 ways are there from in the 3 comma 3 grid to move from starting block to ending block. Total 6 ways are there. You can draw like this, means you can move like this, you can move like this, and you can move like this, and you can move like this, right? You will have a different path. You can move like this. So total six ways are unique ways are there in a 3 into 3 grid. Suppose 4 comma 3 grid, 4 rows, 3 columns. It can be splitted into 3 comma 3 grid and 2 comma 4 grid, because when I move here, I will get 3 comma 3 grid, because when I move here, I will see 3 columns, 3 rows. When I move here, I will see what? I will see 4 rows, 2 columns, right? 4 rows, 2 columns. So when I have 4 into 4 grid, I can be splitted into 4 comma 3 and 3 comma 4 grids, right? Suppose I comma j means I rows, j columns are there. It can be written as I minus 1 comma j plus I comma j minus 1. Means previously you have seen this. 3 comma 3 can be written as 3 minus 1 comma 3, 3 comma 3 minus 1. So 4 minus 3 can be written as 4 minus 1 comma 3 and 4 comma 3 minus 1, right? 4 comma 2. Here I have written as 2 comma 4. It was my mistake, sorry. So I can I can form a one statement here that I comma j grid. Suppose 4 comma 4 grid is there. I can write it as a 3 comma 4 and 4 comma 3, right? So using recursion, you can solve this type of problem also. You can solve this type of problem using recursion concept, because in programming, recursion is very famous to solve this type of problems. So I hope you will understand how to approach from base case to larger case. Means first we will see the base case, we will see the simple thing, and we will see the patterns in it, and we will able to solve the larger question. So every recursion is like this only. So in Fibonacci also we will divide the thing. In factorial also we will divide the things in a simple way. So everywhere we can divide the problem into simple sub problems and then we will solve. So we will see in another video with some good content. I hope you will like this content.